that's how much energy it has. That much. And notice it goes about the same height, which means that that energy is being transferred from one ball to the other. Now, what if I do two balls? How many are going to go up the other side? Two. And so because it has enough energy to make two balls go up. How about if I do three balls?
Three.
Okay, well, let's see what happens. All right, well, three will move. So it has enough energy. Now it's transferring that energy from one ball to the next, from these two balls to those two balls, or those three balls to those three balls. So that's the transfer of energy. And there's transfer of energy, which is to move it from one part of the system to another, which like one ball is transferring the energy to the other ball. And then there's energy transformation to transform it from one side to another, which would be the case of like it's going from chemical energy to mechanical energy or stuff. So anyway, this is an energy transfer. It's a really good example of showing potential and kinetic energy. Because you lift it, that's potential energy. I'll get back into the pendulum stuff a little bit later. I just want to kind of bring this up. It's kind of this is mechanical energy, and it's sort of a transfer of energy going on there. All right, so now let's kind of do a definition of energy. Energy is kind of hard to define. In science, the formulas and stuff, it's the ability to do work. And work is to make something move, right? So it makes stuff happen. It makes things move. So go ahead and let that definition. Yeah, that's Clark Kent. Very few people know he was photographed.
I thought it was Dwayne Johnson.
Well, I don't believe everything you see on the internet.
That's true.
Guys, I thought it was Dwayne Johnson,
Yeah,
the
this
ramp.
little kid's moving a Photoshop. Oh, man, that weighs a ton. Okay, well, the idea here, this kid's doing work, right? He's lifting weight against the force of gravity, which is the technical definition for work. And so, that's why I have that in there. And the different forms of energy. Everybody say mechanical.
Mechanical.
Thermal.
Something.
Nuclear.
Something.
Radiant.
Radiant.
Electrical.
Electrical.
Okay, so in this case, it's chemical energy turning into mechanical, because it's the chemicals, the food in the muscles, the glucose breaks down to the mitochondria to release the energy so your muscles contract, and you turn that into physical motion, right? So the food would be a form of stored energy, which would be potential energy. Okay, so let's go ahead and get a couple of terminologies in here. There's two words that sound very close to each other. There's energy transformation and energy
Oh my god, we
transfer.
tried all of that. Not physical law.
Oh, you'll manage. Energy,
Energy,
the ability to do some work. Okay, energy transformation is when it changes from one form to another. Like changes from chemical to electrical, like a battery. Or radiant to electrical if you go on a solar cell. Or you're going electrical to radiant if you have a lamp. Yeah, what's up?
Isn't it like, doesn't a battery like heat up, like if you put a wire of one end of the battery to the other end of the battery?
Oh, now okay, I'll go ahead and mention that. Yeah, it could also, if you have a resistor, then it would turn the electrical energy into heat. Now, if you get just a battery and put a wire straight from one side to the other, that you got so much current with no other resistors, yeah, it'll drain the battery real fast too. It will heat up. Yeah. So hot enough, I guess it could burn your hand if it was there long enough. But yeah, it could also turn into heat if you have a resistor. Which is also why your phone, does it ever happen to you? You got your phone in your pocket and you put your hand in it and it's been running some program or something, it's all warm.
Oh, like,
Oh yeah.
Yeah, and it's drained in the battery. What's happened is in the background, some program's running. And those electrons running through the circuits have a little bit of resistance and that turns it into heat. That's what uses up the electricity in the phone. Okay, energy transfer is when energy moves to a different part of the system. Like, I don't know. Let's say I throw the ball and I transfer the energy from my hand to, I don't know, let's say I had, hang on. I'm going to try something just for fun. Well, maybe it won't be that much fun, but we'll try it.
Oh yeah.
Oh, yeah.
Oh
yeah.
yeah.
No. Oh, yeah.
Okay. Okay, if I hit this, you guys gotta applaud, right?
Yeah.
Okay, ready?
What? What happened?
Okay.
I bet you.
The point is, I transferred the energy from my hand to the ball, and if I had hit it, which I figure there's probably a 1 in 50 chance of me hitting it,
Can I try?
that would have transferred the energy to the other ball. Okay? So energy transfer is moving energy from one place to another. If you have a battery and you have the electrical wires, it will be from potential energy to kinetic energy, and then you run a fan with it, you're transferring the energy to the fan, but you're also transforming it from chemical to electrical and then electrical to mechanical and to make the motor run. So the movement of the energy is energy transfer from one part of the system to another, and the transformation is when it changes type. Everybody have this written down?
Yep.
Okay, I really want you to know the difference. Oh yeah, let's review this again. What's the law of conservation of energy?
Energy never changes form.
Good. Never created or destroyed and only changes form. It's yellow, so you don't have to write it down. You have it written down already. Okay, now we get to the meat and potatoes of this lesson. I've been kind of summarizing it. Let's do it again. You got to write down stuff down for study. Kinetic energy is the energy of motion. Now, it's not a different form of energy like chemical, radiant, whatever. In addition to that, you can have electrical kinetic energy when the electrons are flowing through the wire. That would be a form of kinetic energy. You can also have electric potential energy when you have a positive and a negative. That is the potential, electrical potential that drives it, that has the force. You can have gravitational potential energy when I lift this. That's a form of mechanical energy. If I let it go, it still stays mechanical energy, but it's turning from potential energy. Oh, what's it called when I let it go? Kinetic energy. Yeah, so this is a different way of looking at it. All these energy forms. I'm not sure if chemical has a form of kinetic energy. I think it does, but the other ones definitely do. Go with that.
Can I use the restroom?
Yeah, you can. Okay, so everybody, say kinetic energy.
Kinetic
Okay,
Energy.
right? Potential energy.
Potential.
This is stored energy, which obviously is important if you're talking about batteries and stuff like that.
So the dynamite and timers don't go well together.
Depending on your purpose, they might go extremely well together. Yeah, so but there's potential energy stored in the dynamite. It can explode. It's not exploding if it's just sitting there on the table, but in certain circumstances, you get the combustion of it going and rapidly, that would be releasing that energy. So that's chemical energy to, well, you get radiant energy, thermal energy, and mechanical energy with the blast, but it's also potential energy to kinetic energy when it's moving. Right? Okay, everybody say potential energy.
Potential
Okay,
energy.
now my favorite example, oops, wrong way. My favorite example of potential and kinetic energy is the pendulum, which, you guys, we did pendulums at the beginning of the year, right? We had those labs.
Yeah.
We measured the factors. Yeah. You know, I wouldn't be surprised if you don't do pendulum labs in 8th grade too. They study mechanics, physics a little bit more than we do in 7th grade. So the deal, though, what I want to show you is this is a great example of potential and kinetic energy. I'm lifting this lead weight here. Watch this. It's pretty heavy, isn't it? Yeah. I gotta admit, this was way more fun doing it with the bowling ball, but I tear this roof down. I had another classroom in Monroe where I thought they had these big wooden beams, and I put a big giant bolt in there, and so I could swing the bowling ball around. Well, I can't do that, but I can do this fishing weight. And now here's the deal. I lift it up, I'm storing that energy in the position. It's gravitational potential energy. If it doesn't have a string on it, I could just drop it and it would fall straight down. And I could turn it into kinetic energy. But since it has the string on it,